The day Mars stopped being a planet and became a destiny. Mars was once just a red in the night sky, distant and silent. Then one day, it became something else entirely. It became a promise we could not ignore. To understand why Mars matters today, we need to go back to a moment when humanity stopped looking outward and started imagining forward. For thousands of years, Mars was a symbol, a god of war, a wandering light. But in the modern age, it transformed into a destination, a place where our future might be rewritten. Because the same forces driving us toward Mars now are reshaping how we see Earth itself. At first, the idea felt almost harmless. Early astronomers saw patterns on Mars and wondered if they were canals. Some believed an ancient civilization had engineered them to survive a dying world. It wasn't science fiction yet. It was scientific curiosity colliding with hope. Mars became the first place where we projected our fear of extinction and our desire to escape it. Then technology caught up with imagination. Telescopes sharpened. Data replaced guesswork. Mars lost its fantasy and gained detail. Its surface revealed deserts, frozen poles, and scars carved by ancient forces. But instead of killing the dream, this clarity made it stronger. Mars no longer needed myths. It had history. What stunned scientists most was evidence of water, riverbeds, minerals shaped by liquid flow, proof that Mars was once warm, wet, and possibly alive. That discovery changed everything. Because if Mars could lose a world, so could we. And suddenly, Mars wasn't just a planet to explore. It was a warning written in stone. As space agencies sent probes and rovers, each mission rewrote our relationship with the red planet. Mars became a testing ground for survival, a laboratory for endurance, a mirror reflecting what happens when a planet's balance collapses. The question quietly shifted from can we go there to should we learn from it? And beneath every mission, every headline, and every promise of colonization, one deeper truth began to surface. Mars didn't choose us. We chose Mars, not because it is friendly, not because it is easy, but because it represents the moment humanity realized Earth may not always be enough. Mars did not invite us closer. We pushed toward it anyway, driven by questions we could not silence. As probes traveled millions of kilometers, they carried more than instruments. They carried human anxiety, curiosity, and ambition compressed into metal and code. With every successful landing, the story deepened. Mars was colder than expected, drier, more hostile. Its thin atmosphere offered little protection. Radiation washed over the surface endlessly. This was not a backup Earth. It was a reminder of how fragile habitability truly is. Yet the missions kept coming, each one revealing a planet that once had everything needed for life. The persistence of exploration despite mounting evidence of hostility revealed something profound about human nature itself. Scientists began reconstructing Mars's past piece by piece. Billions of years ago, it had oceans. Rain fell from its skies. Volcanoes reshaped its surface. A magnetic field once shielded it from solar violence. Then something went wrong. The core cooled. The shield collapsed. The atmosphere slowly bled into space. Mars did not explode or burn. It faded. That gradual diminishment proved more haunting than any cataclysm, because it suggested that endings do not always announce themselves. That slow death disturbed researchers more than any catastrophe ever could, because it showed how planets can fail quietly. No warning sirens, no dramatic end, just gradual loss. The kind that is easy to ignore until it's irreversible. Mars became a case study in planetary mortality. Its silence spoke louder than any alarm, demonstrating that the universe does not accommodate complacency. As rovers rolled across ancient lake beds, they uncovered chemical signatures hinting at life's building blocks. Not proof of organisms, but proof of possibility. That distinction mattered, because possibility meant responsibility. If Mars once supported life, then our presence there carries consequences we barely understand. The ethical weight of exploration grew heavier with each discovery, transforming missions from purely scientific endeavors into moral undertakings. At the same time, public imagination shifted. Mars was no longer just a scientific target. It became a symbol of escape, a second chance, a place where humanity could start over if Earth failed. But this idea carried a dangerous assumption: that survival is about relocation, not preservation. The fantasy of departure obscured a reality that no destination can substitute for responsible stewardship of the world we already inhabit. Quietly, a tension formed between exploration and exploitation, between learning from Mars and using it, between protecting a silent world and reshaping it to suit us. And as plans for human missions accelerated, that tension grew sharper. The debate extended beyond engineering feasibility into questions of philosophy, ethics, and long-term consequence. Mars began to feel less like a destination and more like a decision, one that would define whether humanity explores with humility or repeats the same patterns that turn a living world into a frozen memory. Mars was once alive, and we ignored the warning. For billions of years, Mars carried the conditions needed for life. Then it lost them quietly and completely, and humanity barely noticed until it was too late. That delayed recognition represents one of the most significant failures of attention in scientific history, a failure whose consequences extend far beyond planetary science. To understand why this matters today, we have confronted an uncomfortable truth. Mars did not fail suddenly. It failed gradually, in ways that were almost invisible at first. That makes its story urgently relevant to the modern world, because the same slow processes that reshaped Mars are now being studied much closer to home. The parallels between planetary decline and contemporary environmental concerns grow sharper with each passing year. At first, Mars looked promising. Its surface showed valleys carved by flowing water, minerals formed only in wet environments. Evidence stacked quietly mission after mission. Mars was not always cold and dead. It was active, dynamic, and potentially alive. That realization forced scientists to rethink how common life might be in the universe. The implications extended from biology to philosophy, reshaping humanity's understanding of its cosmic context. But understanding came late. By the time we recognized what Mars had been, the planet was already frozen in its final state. Whatever life once existed had vanished, leaving only chemical traces behind. Mars became a fossilized world, preserving its past but unable to recover it. That irreversibility stands as the central tragedy of the Martian story. The warning was there all along. A planet can lose habitability without dramatic collapse. Stability can erode slowly, unnoticed by those living through it. Mars showed that life does not need an asteroid to end. It only needs time and imbalance. That lesson challenges assumptions about catastrophe being the primary threat to existence. As data accumulated, a deeper narrative emerged. Mars once had protection, energy, and circulation. When those systems weakened, everything else followed. Water escaped, atmosphere thinned, climate drifted beyond repair. Mars crossed a threshold it could not reverse. Each loss enabled the next, creating cascades that no intervention could halt. Yet even as these discoveries mounted, the warning remained abstract. Mars was distant. Its failure felt theoretical. And so its story became a curiosity rather than a lesson. The gap between knowledge and response revealed something troubling about human cognition. But Mars was never just telling us about itself. It was offering a glimpse of what happens when planetary systems lose balance. And that message is far harder to ignore now. As scientists reconstructed Mars's history, the pattern became clearer and more unsettling. Mars did not lose life because it lacked potential. It lost life because it lost protection. And once that protection was gone, recovery was impossible. The sequence of failures followed physical laws that apply everywhere. Early Mars had a strong magnetic field. It shielded the planet from solar radiation and held the atmosphere in place. This invisible barrier allowed water to remain liquid and temperatures to stay stable. Life, if it emerged, had time to develop, but that shield did not last. Its disappearance marked the beginning of irreversible decline. When Mars's core cooled, the magnetic field weakened. Solar winds began stripping the atmosphere away molecule by molecule. The process was slow enough to escape notice, but relentless enough to guarantee collapse. Water evaporated into space. Climate systems unraveled. Mars crossed a line without realizing it. The transition from stable to doomed occurred without fanfare. This is where the warning becomes sharper. Mars did not collapse from excess change. It collapsed from gradual loss, from small failures compounding over millions of years. The kind of decline that does not trigger alarms until nothing can be done. That pattern of incremental deterioration applies to systems far beyond planetary atmospheres. Rovers later confirmed this story etched into the ground. Ancient shorelines, delta formations, minerals that only form in stable water. These were not signs of a brief experiment with habitability. They were signs of long-term balance that eventually failed. The geological record preserved evidence of what once existed and what was lost. Yet when these discoveries were announced, they were framed as triumphs of exploration, proof that we had uncovered Mars's secrets. Rarely were they treated as cautionary signals. The planet's death became data, not warning. That framing represented a missed opportunity for deeper reflection. Mars teaches a difficult lesson. Planetary health is not permanent. It must be maintained continuously. Once key systems weaken, collapse accelerates silently. Mars did not announce its end. It simply drifted beyond recovery. The quiet nature of its demise makes it more instructive, not less. And that quiet ending is what makes its story so dangerous to ignore. The conflict in Mars' story lies in how easily its collapse was misunderstood. For a long time, scientists searched for a single cause, a catastrophic event, a dramatic failure, something obvious enough to explain everything at once. But Mars refused to provide one. The planet resisted simple narratives. Instead, its decline unfolded through interconnected weaknesses. As the magnetic field faded, radiation increased. As radiation increased, water stability decreased. As water disappeared, atmospheric pressure dropped. Each step amplified the next. None of them alone seemed fatal. Together, they were irreversible. The complexity of the collapse made it harder to comprehend and easier to dismiss. This is where the warning becomes most unsettling. Mars did not suffer from one mistake. It suffered from delayed response. The systems that kept it alive weakened slowly enough that no immediate crisis demanded action. By the time the damage became visible, the planet had already crossed multiple thresholds. The window for intervention had closed long before the problem was recognized. On Earth, we often assume resilience is automatic, that systems will adapt, that balance will return on its own. Mars proves that assumption wrong. Resilience has limits, and when those limits are passed quietly, recovery becomes impossible. The planet stands as evidence against complacency. The day